I would like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. Thanks again for joining us for today's presentation, TechNet Webcast, How to Build a Private Cloud. Now it is my pleasure to introduce today's presenter, Chris Henley. Chris, you now have the floor.
Scott, thank you very much, and welcome to all of you. Hopefully you're joining us to talk about private cloud today, because that's what we're going to talk about. We're going to give you an overview of what private cloud is all about, and hopefully by the time the session is over this morning, you have a good understanding of what we mean when we throw out that term private cloud. Now, I like to do research. I've always enjoyed learning. I do a lot of reading. I was out looking at Wikipedia's website yesterday. Wanted to see what they had to say about the word private cloud, and I came across a notation there on the Wikipedia site that said that the term private cloud is actually considered by many as something called a neologism. Now there's a word for you. Neo meaning new and logo meaning word. Neologism is something that we would consider new in terms of its meaning or its usage in the English language, and private cloud kind of fits, right? We're familiar with the term private, and we're familiar with the term cloud, but when we throw the two of them together, some of us know what they mean, sort of, and most of us look at it and say, what exactly is private cloud, and why would I want one? And hopefully we can answer that question today. In order to answer that question effectively, what is private cloud? Why do I want one? How can I build one? What's the process and components necessary to make one of these things? We really actually have to go back in time, and we need to go back to about 2005. Now, if you worked with me recently, you know that I've been using this slide with Ray Ozzie and the focus on the Internet Service Disruption Memo. Now, he released this memo on October 28, 2005. He sent it to the executive staff and their direct reports at Microsoft. And his title simply said the Internet Service Disruption. Now, I pulled out a couple of what I think are real key segments or key quotations from this memo that are shaping today's operation from a Microsoft perspective and from a larger IT and development perspective. First quote's there on the far right. Complexity kills. It sucks the life out of developers. It makes products difficult to plan, build, and test. It introduces security challenges, and it causes end user and administrator frustration. And Ray Ozzie is absolutely right. Second one, many startups treat the raw Internet as their platform. Now, the focus of this Internet Services Disruption memo from Ray Ozzie, and you can see the link there at the bottom. If you want to go out, CNET still has this memo available. You're more than welcome to go and read it. Key focus for us is this. Microsoft will continue to build operating systems. They will continue to build applications just like they've done in the past. So for those of you thinking, will there be a Windows 8? Yes, there will be. Will there be another version of Windows Server? Yes, absolutely, there will be. Will we still see Microsoft Office released in DVD form? Absolutely. We'll still continue to see those things. That software model is heavily entrenched in the way that we do business and heavily entrenched in the way that we use personal computers at home. We aren't going to simply drop that model. However, it's also very clear to Ray Ozzie all the way back in 2005, so going on 6 years ago, coming up on 7 years now, that we're probably going to transition, and instead of using just a straight software model to do business, we will likely also use a service-based model to do business. And you see it there in an inkling in that quote that many startups treat the raw Internet as their platform. And by raw Internet, what we mean here, what Ray's talking about, is a set of services that can be offered without an operating system. So, for example, you might find a software program that's offered online as a service. Now, that concept was relatively new in 2005, and it's come to be known as software plus services. Now, in the Microsoft world, we're starting to look at the software plus services model across 3 different screens. So we look at it and we say, okay, PC is really important. Phone, really important. TV, really important. Now, the mix of those, PC, phone, TV, and even what we term a PC and what we term a phone and what we term a TV is starting to blur. What's not changing is the fact that people still use Windows, they still want Office, they still use applications that are based on something like the .NET platform. They want browsers so that they can surf content online through something like, say, Internet Explorer. They're looking for advanced methodologies to deliver that content to them through things like Silverlight, HTML5. They're looking for compatibility with other programming languages. So as I start to think about using Ruby or Python or PHP, or maybe I want to go with a traditional Visual Studio approach, all of those tools need to be available and functional in a single environment. Now, whether we're talking about the client side or the server side, which would include the traditional family of Windows servers like Windows Server, SQL Server, System Center, SharePoint Server, all of those guys, we left Exchange off. We better throw Exchange Server into that mix as well. Those traditional servers we still expect to see in play. Now, what Ray's comments introduced in 2005, and when I say introduced, that's probably not the right or appropriate term. While those concepts were new, Ray kind of started to drive them into our business, and Microsoft as a company, which is a really, really big company, changed our focus. And we changed it very, very strongly. Went a different direction. And the different direction you can see in our cloud-based offerings on this particular slide. So we put SharePoint services, SQL services, Windows Azure, all as cloud-based operations, but there's actually more to that. And we'll talk about what the more to that is. When we think about the idea of a client, a server, and a cloud, and you combine those three components together, and we start to stretch what we do with those devices and with those services and with those servers, wow, the opportunities that are out there are really amazing in terms of what you can deliver to the clients that are working inside your organization or to the clients that are not necessarily your organization but might be your customers or might be your partners. When we think about the idea of cloud, I want you to get an idea of where this fits. Because, frankly speaking, going out and building a private cloud is awesome on its own. But when you combine it with this idea of cloud services, traditional server services, and then client operations, that's where the real power of this whole discussion comes from. Many of you out there have been working with virtualization. And I'm assuming that you've probably worked with virtualization in both of its component types. You've probably run Type 2 hypervisors or hosted hypervisor models like VMware Workstation, Virtual PC 2007, Virtual Server 2005. Those products are all Type 2 hypervisors. You've probably also worked with Type 1 hypervisors. That would include Microsoft's Hyper-V, ESX, Zen from Citrix. All of those would be true Type 1 hypervisors. Now, the beauty of working with virtualization is kind of fourfold, and I put the four key pieces of the virtualization argument on the slide. The first and probably most compelling reason to move to virtualization is because I can drop my capital expenditure costs significantly. I'm not shelling out tons of money to buy new resources, meaning processors, memory, network, and disk, to run servers. The second reason that we like virtualization is because virtualization, Hyper-V virtualization, increases my hardware utilization percentage on the hardware that I've already purchased. Instead of running somewhere in the 15 to 20% range, now with virtualization, I can run in maybe the 70 to 80% range comfortably, get much better utilization, and again decrease my cost. Hyper-V decreases physical server sprawl, and that's really a big deal for us. For the past how many years now, Microsoft has been recommending that each time you run, say, an Active Directory server, it runs on its own physical server. And, oh yes, by the way, you probably ought to have an additional one for redundancy. And Exchange should not run on the Active Directory physical hardware. Exchange needs to run on its own set of hardware, and oh yes, you probably ought to have another for redundancy. When we add SQL, and SharePoint and other servers as well, we end up with a server sprawl model that has real easy growth potential. And we saw this happen throughout the 90s and throughout the 2000s. Well, with virtualization coming online, we can start to do server consolidation. And we can start to consolidate roles, which is our last major benefit here. We can start to consolidate servers and consolidate roles, and so that we still get the same and in some cases even better performance in terms of the services that we offer, but at the same time decrease the total number of physical servers that I need to administrate. Those four things have really driven the idea of virtualization into most of our organizations. It used to be I'd walk into a client business and they would rarely have virtualization in place. Today, not the case. Today it's rare to walk into an organization and not have them be virtualizing at least some of their workloads because it just frankly makes sense to do that. Now, unfortunately, we start to ask questions when we start thinking about virtualization that have really good answers, but they aren't answers that are necessarily supplied by something like traditional Hyper-V. Now, what I mean by that is this. If we start looking at the idea of server consolidation, for example, and we start consolidating hardware, or excuse me, we start consolidating servers onto hardware platforms, and we start offering services, and we start treating hardware like resource pools, which is the right term to use with Hyper-V, you know, in the back of our mind, eventually we start to think, gosh, this looks a lot like the way I used to do my web-based model. I mean, we started with the idea that, oh, I'm going to build a web server, and then I'm going to host my own web content. And then we realized, wow, that's a big capital expenditure to buy my own web server. Maybe I ought not to do that. I suppose we could run the web server in a virtualization-style environment, but it might be even better to just skip purchasing the hardware altogether, pass that hardware cost out to someone else, a hosting company, for example, let them purchase the hardware, and we'll just purchase some time. That way we can run our website on their hardware. I don't buy the hardware, I just pay for what I use. And that pay-as-you-go model, that lease-based model, looks and feels really, really good in the web-based environment. I wonder why we don't do that with our traditional virtualization hardware. I mean, frankly speaking, we could lease that hardware from someone else, use a pay-as-you-go model, and that seems very logical to me. Now, apparently it seemed really logical to other people too, because since 2005, Microsoft has been building data centers. And not just any old data center. It's Microsoft. We cannot do it halfway. We're going to go over the top, and we have. So there's a website out there, it's called datacenterknowledge.com. Data Center Knowledge has a list on their website of the 10 largest data centers in the world. Now, you'll notice, looking down the list, and I threw their pictures here on the screen for you, that 4 of those data centers belong to Microsoft. Now, I know you're thinking, hey, there's only 3 circles. Well, you'll notice that number 9A and 9B are the Microsoft data centers located in Quincy, Washington, and San Antonio, Texas. Apparently, we didn't want to just push number 10 off the list because 9A and 9B are technically twins of one another, and you can see them on the left side of the slide. The one at the top is Quincy, the one at the bottom left is San Antonio. Those data centers are 470,000 square feet. They represent what Microsoft did in terms of initial evolution of a data center. Now, if we were to look at these inside, you would find that these data centers are very different from what we're traditionally expecting to see. Microsoft has adopted and published a model for data centers where we put more than just hard drives in our data centers. They have a nice mix and balance of processors, memory, network connectivity, and disk space. They are located next to facilities that provide them with low-cost electricity, and as such are often called green data centers because we can do some pretty cool things that reduce the expenditure of resources. The Number 6 and number 5, Microsoft Dublin is the image in the bottom center of the slide. The Dublin location is listed at number 6. An interesting side note here, number 6 would be the data storage that's actually inside that facility. If we were to take into account the storage that occurs outside the facility, remember we're trying to keep these data centers cool. Ireland is a great place to do that. We store the shipping containers outside, in the backyard, literally. If we counted the ones in the backyard, this would move much farther up the list. And of course, we have a container center in Chicago, Illinois, which lists there at number 5. That's the bottom right-hand side of the screen. I know it looks like a much smaller footprint. It is a smaller footprint than Quincy or San Antonio. We built the walls taller so we can stack the data centers inside. The higher you stack the centers, the more content you can get. Why in the world does Microsoft need at least 4, and actually the answer here is Microsoft has somewhere between 5 and 100 of these around the world. Why do we need big data centers? Well, it kind of goes back to the question that we asked on the previous slide. If I'm running virtualization, why would I want to buy hardware? It would make much more sense for me to lease hardware from someone else. And Microsoft would like to be that someone else. So everyone asks, how are you going to do that? How am I going to lease hardware? And what kind of hardware am I going to lease? And this is where the question starts to kind of divulge into a series of different topics, and we start to think about things in terms of what we want to do instead of how we want to do it. Does that make sense to you? Now, in the past editions, when we ran a standard software-based model for our IT infrastructure, when we started to think about what we wanted to do, usually the first question is, what do we need to buy in order to do it? So if we said we wanted to host email for all of the individuals in our company, well, how many servers will we need, and which email software will we run? Those were the questions that we started to talk about. Then we would address connectivity issues. Then we would address software like Microsoft Outlook for all of the client machines in our organization. Well, today, when we start to think about offering a solution to our business, we still have the same software-based approach out there, but we also have what we're going to call the as-a-service approach. And I just call them the AASs. Be careful doing that. I just noticed that doesn't look really good. The AASs come in 4 types. The first type, called infrastructure as a service. Now, infrastructure as a service is a very much hosted style environment where you're going to go in and pay for hardware and pay for nothing else. Now, the infrastructure as a service offering that's probably most well known out there in the world today would be Amazon's infrastructure as a service offering. Amazon had all of this data center space. They realized, hey, we could make some money with this data center storage space by letting companies come in and load their stuff. Now, when I say load their stuff, what I really mean here is build their virtual machines on our hardware. They can lease that hardware from us. When they're done using it, lease is over, no more cost, no upfront capital expenditure for hardware for the business, still operational, and it's pretty fast to get your stuff up and running. Now, Microsoft even issued their own license for Windows Server so that you could run that as a virtual machine on Amazon's infrastructure as a service offering. Now, you'll notice I put TBA, to be announced. Microsoft at present does not have a traditional infrastructure as a service offering. And there's a reason behind that. We're going to talk about it here in just a second. But at present, Microsoft does not have a traditional infrastructure as a service offering. Now, I've seen some interesting stuff go by in my email that makes me think we'll probably do something in the infrastructure as a service space. Now, what and when and how much it will cost, all of those are questions that I don't honestly know the answers to. We're still working on that as a company. But there will be something in the infrastructure as a service space from Microsoft. Now, the reason that we haven't done infrastructure as a service until now is because, to be quite honest with you, when we look at what's available out there in the marketplace, infrastructure as a service doesn't seem like the most important offering. In fact, we put it last in terms of offering. Why? Well, software as a service, that second one, seems like one of the more important offerings out there. In a software as a service model, instead of paying to get access to hardware so you could load your virtual machine, so that you could load a server so that you could provide a service, it seems like you would prefer not to pay for hardware, not to build a virtual machine, and not to pay for physical software. Instead, it would be much better if someone else, Microsoft for example, would simply host the application that you want in a online environment and then simply allow you to consume it. That methodology is so effective. Now you got to give kind of the first to the marketplace award in this category to Salesforce.com. Salesforce developed what we consider one of the most popular and early on software as a service platforms. Now, if we were to go back, you'll find that there are a number of software as a service offerings that came long before Salesforce.com. I don't know how many of you have used Outlook Web Access. We've been doing this with Exchange for years and years and years. If you've been getting your email online, you have a software as a service model already in use. If you used Hotmail, if you used Windows Live and your Windows Live account, those are all software as a service offerings, and we will continue to do those. Now, you're also aware that Microsoft is currently offering something called Office 365. This is without a doubt the most mature software as a service offering that is available today, not just from Microsoft, from anyone. That software as a service offering would include Office, Exchange, SharePoint offerings as well, and the ability to do communication. Link. That's an amazing software offering. Now, please keep in mind here, again, no virtual machines built by you, no hardware acquisition costs for you. All we're talking about here is a lease for software program. And at present time, Microsoft will actually send you the physical software Office as well because of your subscription to the online version. So amazing in terms of its offering. Now, we also realize that there are many different products out there that are not made by Microsoft. In fact, you're going to want to build your own applications that are mission critical to your business but need to run in this as a service style environment. Now, you're likely going to build those applications to run atop one of a couple of platforms that are out there. You're going to build it to run on top of Windows Server, or you're probably going to build it to run on top of Linux, one of those two. Now, obviously, my recommendation is build it for Windows. If you're going to build it for Windows, you're probably going to use a standard development tool set like, say, Visual Studio. You'll probably use a .NET platform to build with. That is not a requirement. You could use PHP, you could use C++, you can use essentially whatever you'd like, right? Use a set of development rules that works on top of Windows Server. If you'll do that, the next logical step is, why would I run it on Windows Server? Again, remember, I don't want to buy the hardware and I don't want to buy the operating system if I can help it. So how do I get around that? Well, Microsoft has a platform, Windows Server, that runs on top of hardware that Microsoft will host, and you simply write the application to run on top of Windows Server. Now, rather than calling that Windows Server in the cloud, we gave it a different name. We called it Windows Azure. Now, Windows Azure is nothing more than a virtual machine running a custom version of Windows Server 2008. That virtual machine has amazing possibilities for you. What it means is that you have the ability, using Windows Azure in a platform as a service model, to scale extensively, to have essentially unlimited processor, essentially unlimited disk space, essentially unlimited network bandwidth. You can pick and choose. Essentially unlimited memory. The point here is this is a cost-as-you-go or a pay-as-you-go model, and we're going to continue to see this become more and more and more popular. Now, for those of you that are thinking, hey, that is cool, but I don't want to have all of my applications and all of my data stored in a public environment, in a Microsoft data center in Quincy, Washington, or San Antonio, Texas, or Chicago, or Dublin, or anywhere else. I need that stuff stored locally, but I want all of the cool benefits that I get from the platform as a service, software as a service, infrastructure as a service style offerings. Well, we would define that last option of I want to keep things in my own organization, but I want all the benefits that come from running those software as a service, infrastructure as a service, platform as a service offerings. We call that IT as a service. And in particular, Microsoft will call that private cloud or Hyper-V cloud. Now, there is no coincidence that we call it Hyper-V cloud because Hyper-V is instrumental in making sure that this works. Out there in the world today, we have something that I'm going to call the cloudscape. And it's worth stopping to talk about the cloudscape for just a minute. When you look at this slide, you're going to hear the term cloud thrown around in the world of business today. And in many cases, what a company may call a cloud is really only a part or parcel of what that actual term might mean. Now, I put this slide together for you so that you can get an idea of what exactly it might mean to think about cloud. So you have what we would call a public cloud. And in a public cloud environment, we would expect to find infrastructure as a service offerings, platform as a service offerings, software as a service offerings, large-scale data centers, a set of amazing management tools that allow me to control, operate, scale up and down what's going on with stuff inside of that public cloud environment. We would also expect to be able to find a couple of things, and these are actually unique to Microsoft. In a public cloud environment, I want to be able to have either the option to use what's called shared public cloud resources, meaning I realize that Microsoft's data centers, for example, are built using diesel trailers that have processors, memory, network, and disk. If I use a shared environment, I realize that my information, data applications, whatever it is that I put in that environment, are going to be inside of one of those data centers that is shared amongst a large group of other companies, organizations, or individuals. I also understand that there may be things that I do that I don't want to be in that shared style environment. So I may want to use a quote-unquote public resource, Microsoft's data centers. However, I want that resource dedicated specifically to me. Now, we would transition that over and we would call that a dedicated cloud. It still has infrastructure as a service, platform as a service, software as a service components, but now we're starting to slide the rule away from a shared cloud environment and into an environment where I start to get dedicated resources. So maybe I say, you know what, I want a diesel trailer of processor, memory, network, and disks, one of those portable data centers that is dedicated just to my usage. So I start moving the pendulum from shared public resource towards one that is very private. Now, in this case, dedicated cloud still maintains the same resources. I still have the same Azure components. I still have, the software as a service options. I still have all of those things. But I'm starting to provide a dedicated resource specifically for my organization. What if I want to go further? What if I'm not interested in having my storage, for example, for mission-critical data be housed in the cloud? What if I'd like that stuff to come back to my organization? I want it to operate entirely within the bounds of my own business enterprise. But I still want the benefits associated with software as a service, infrastructure as a service, platform as a service particularly. How can I do that? Well, we would call that private cloud. Now, the difference here is that as I move that into my organization, I took on the capital expenditure costs associated with purchasing the hardware necessary to run those cloud-based services. Now, the nice thing about this, and you can see this from the slide, is that private cloud can be connected to public cloud cloud can be connected to dedicated cloud cloud can be connected to private cloud, and all of this can run in an international style environment. So I have lots of opportunities when I start thinking about what the cloudscape is actually like. Now, as we continue, what I'd like to do is spend just a couple of minutes talking to you about the Azure platform. Now, there is method to my madness. I know that many of you are thinking, hey, I came here to talk about how to build a private cloud, and you're talking about the Windows Azure platform. I am, because the Windows Azure platform is going to be something that is critical to your private cloud operations in the future. As such, we're going to talk about Windows Azure. Now, I will spend a few minutes talking about what Windows Azure is, what its components are, and hopefully in a few minutes, about 10 of them to be precise, you'll get an idea of why we talked about Windows Azure when what you came to learn about was private cloud. Now, when we think about this idea of platform as a service, we need to think about the Windows Azure platform. And I told you earlier that Windows Azure is just a nice name for Windows Server 2008 virtual machine. Now, this Windows Server 2008 virtual machine is running in a Microsoft data center. Those virtual machines have the ability to scale out and up, meaning I can have more and more and more and more instances. Those platforms have the ability to integrate with other Azure components. So the Windows Azure platform is also made up of additional components like SQL Azure. Guess what SQL Azure does? If you're thinking, hey, it's probably a relational database operating in a cloud-based environment, you're right on the money. There's something else on the slide. Windows Azure App Fabric. What the world is that? It says Service Bus and Access Control. What does it actually mean? Web services, applications, on-premises applications. Let's review this in a little bit more detail. When I think about working with Windows Azure, the reason I like Windows Azure and the reason that we like platform as a service offerings in general is because they are very much analogous to what I find with Hyper-V. Now remember, in Hyper-V, we're working with a manager that is going to manage a set of resources, right? We stopped thinking about individual servers and saying, oh, I've got a server here in this office and 2 servers in that office, and we started thinking about them in terms of resource pools. And we said, okay, hard drive locations might be a RAID array here, a SAN over there, a SCSI drive here, a attached piece of storage here, and we're going to abstract all of those and simply make them a storage resource pool in Hyper-V. Hyper-V was incredibly valued because of its ability to abstract resources into resource pools and make administration just so much easier. It also added the benefit to us, because we could make those resource pools, it was easy for us to find where the most logical place for me to put a virtual machine inside my organization would actually be. Where's it going to run the best, the fastest, and have the most resources? Well, when we think about that, really that's what we want to do with Windows Azure as well, right? We want to provide resource access with a level of abstraction, and the way we do that is with Windows Azure. Only in this case, you don't have to buy the resource. You put Azure out into a cloud-based environment, and it provides abstraction and access to those resources for you. Now, when you think about Windows Azure from an architectural perspective, the thing that's probably most new or interesting to the IT professional is something called the application fabric or the fabric controller. Now, the application fabric, when you think about Windows Azure, the application fabric is really just nothing more than a set of all of the platform operational components that are out there in that cloud environment. So we're talking about storage, we're talking about processing power, we're talking about individual virtual machines, we're talking about network capacity, memory. All of those things are a part of this large piece called fabric. Now, that fabric can be controlled through the use of something called a fabric controller. Now, the fabric controller communicates with every server inside that fabric, and then it manages the Windows Azure operating system. It monitors the application and decides where new applications ought to run, and then optimizes the hardware utilization for us. That's a lot like what we used to get out of Hyper-V when we were running things locally. The difference here is, with Windows Azure, I'm not buying the hardware. We're simply letting the Azure Application Fabric and the Fabric Controller define, hey, it's time to run a new instance of this virtual machine, or it's time to run a new instance of this application that I've loaded onto Windows Azure. Now, The cool thing about this is that when I start thinking in terms of my regular IT environment, what I really want to get out of my IT environment is I want to swing my core I/O focus all the way over from the basic side where I'm doing everything, my administrative staff is constantly working, over to the dynamic side of the equation where my IT staff is focused on solutions, not on day-to-day operations. When I think about a dynamic resource or a dynamic IT environment, I know that services are being managed automatically. I know that storage services are being managed and maintained automatically. I know that my virtual machines or virtual applications, my compute is being scaled up and down automatically. The idea behind this is that I want to be able to use state-of-the-art data centers to get automated IT resource management, and Windows Azure provides that capacity. Now, if you're thinking to yourself, oh, now I see why Henley wants to talk about IT resource management in Windows Azure. Now, while this is not a private cloud, it is exactly what we want our private cloud to do. When we think about compute services inside of Windows Azure, one of the things that we love about this tool is that it has massive scalability. I want to be able to scale out and out and out and out by adding additional what we call web worker role instances, and I want to add them on an as-needed basis. That way, as I have increasing demand for the resource that I'm offering, Windows Azure can simply take that request for demand and fill those needs. I don't go without operating capacity. And the compute services in Windows Azure are phenomenal for that reason. Now, I told you that there are a couple of different roles in Windows Azure, and this is not necessarily incredibly important that you understand right now. It will be important as we start going into more detail in the coming weeks. But there are actually two different roles in Windows Azure. There's one called a web role and one called a worker role. Now, the web role actually is the one that we use to interact with the end user or with the web service. Now, the thing about the web role is that it will communicate with the worker roles either directly or via a queue. Now, the worker role says, hey, I'm going to take requests for data or tasks from the queue from the web role. This would be a lot like doing, say, like a batch job or maybe even a traditional Windows service. So it's just kind of waiting for something to make a request. When it does, we take the request, we fulfill the request, and we pass it on back to the web role. In Windows Azure, we use web roles and worker roles, and they provide the basis for the communication between applications and services. Now, you're going to want similar functionality in your private cloud. Storage services in Windows Azure, also very important. We want scalable, durable, utility-based storage. Now, because of that, we're not going to give you just a single type. Instead, we're going to transition and move from just a standard drive storage model like we might have used in the traditional server environment, and we're going to start talking about storage in 4 forms. We're going to use blob storage, table storage. Now, this is not the relational database table that you're thinking of. In this case, a table is actually a very broad table with not a lot of detail. We're talking about individual objects with a small set of properties associated with them. So we're not talking relational database tables here. We're talking about storage tables. Queues, we talked about queues just a second ago. A queue, a place where a web role might store something while it waits for the worker role to come and take action. And then, of course, we have the traditional drives like you're used to using. In this case, you could actually build a logical drive and then use it as storage in Windows Azure. Now, the nice thing about this, again, it's scalable. You don't run out of storage space. The Azure application can use native storage, could use MySQL, could use virtual machines, could use SQL Azure. You get all kinds of options in terms of how you want to use the storage. Now, the cool thing about this, and I'll just kind of throw this out because I think it's the way business should be done in the storage world, if you were to use Azure in either the public cloud or the dedicated cloud environment, when you drop stuff into this storage model, Microsoft makes 3 copies, does it immediately. And based on what your designations are, we store it in locations that could be as diverse as globally, nationally, in a single state, or even in a single data center location. You provide that. When you think about these different types of stores, I wanted to put together some basic info so that you understood exactly what I'm talking about. A blob storage is a simple interface for storing name files along with metadata for the file. A table, structured storage. This is a set of entities that contain a set of properties. Remember, not a relational database table. Queues, reliable storage and delivery of messages for an application. They're a holding pen between web roles and webworker roles. And, of course, drives are a standard, durable NTFS file system volume that can be shared across multiple instances. When we think about Windows Azure, I've got tons of compute power, processor like nobody's business. I have incredible memory resources accessible to me. I have an unlimited amount of storage space that is accessible to me. I have a huge network pipe. With those four key pieces, I can essentially provide whatever service I might choose, whether to my internal customers or to the external customers that I serve. Now, the thing that we have not talked about and that is probably missing more than anything else in our discussion is that I need to understand how exactly I'm going to manage those amazing resources. And the way that I manage those amazing resources is through the use of something called a fabric controller. Now, earlier we said that the fabric itself was the collections of servers, and that those servers might be running virtual machines, they might be running multiple services per virtual machine. You can see some of the basics on this slide. The controller is going to manage all those fabric components. Now, the interesting thing about the controller is that you actually tell the controller what to do, not how to do it. And that's a major transition for us in the IT world, right? My job in the old days used to be how to do it. The CEO, CIO, CTO came to us and said, what I'm interested in having happen is I want to make this service available to these individuals, and our job was how. With the fabric controller, that isn't what we work on. Instead, with the fabric controller, we tell the fabric controller what we want it to do, and it figures out how. So we might tell the fabric controller, for example, I want 15 instances to begin with of a virtual machine running a application for my organization. At that point, the fabric controller goes out and looks at the available resources and says, all right, here's how we should do it. We'll put one virtual machine on this hardware set, another one here, another one here. We'll make duplicate connections for redundancy between these machines on these locations, and here's where the storage will run. That's a dramatic change for us as IT professionals. The beauty of this is that we can provide the what we want to have happens, and we can let the fabric controller take over and automatically scale up, scale down, update, roll applications back. The fabric controller can take over and automate those processes. Now, the cool thing about this, in my opinion, is that I kind of get this set it and forget it mentality, which I love to do in IT. So I go in and I make the configuration files associated with what I'm running in Windows Azure, and if we were to use, say, a web-based application as our example, I can now start to tell the fabric controller what I want to do. I want to make sure, for example, that my web-based application does not let any user request from a public environment go unfulfilled. In relation to that, I want it to continually spin up new instances of this web service as soon as it reaches, say, I don't know, 70% capacity. And I want that to continue until my cost reaches a given point. That's kind of interesting, huh? So the fabric controller can automate our processes on our behalf. Now, that doesn't mean that we no longer look at what's going on. In fact, the opposite is true. You're still going to be a resource manager. That's going to be our role in IT. We're going to manage our resources for our business, and we're still going to look at what's happening, but it's just that. We're looking now at what's happening with our fabric controller and our online automated IT environment instead of making it happen. So our role changes a little bit there. Now, of course, you can go back and adjust those files in your Fabric environment. The Fabric controller will interact with Fabric agents on each machine. It'll monitor every virtual machine, every application, and every instance. It'll perform load balancing. It'll do checkpoints. It'll do recovery. The Fabric controller is the key component for automating a platform as a service environment. Everybody asks this question, and it's one that we cannot ignore, and it provides us the transition to what we want to talk about next. What is security like in Windows Azure? Well, let me tell you, it's phenomenal. And with that said, I want to break it down into kind of 4 key subcomponents. Physical security at a Microsoft data center is state-of-the-art. It's got redundant power supplies, separate providers, battery and diesel backup generators, climate control systems, fire prevention and suppression systems. The physical security is exceptional. State-of-the-art. Our continuity, I've shown you some of the images of the data centers. We provide multiple centers in different geographies. User chooses single location, geographically distributed data centers. All of our data is replicated multiple times, and the Fabric is designed to be backed up and restored from given checkpoints so we don't lose stuff. Logically speaking, Windows Azure has been optimized for cloud access with no admin access to guests or to applications. So the logical controls, logical security is also excellent. And then, of course, compliance and certification. Microsoft's incredibly committed to complying with local, state, federal, international legal and regulatory compliance regulations. Industry certification is a core part of our Azure roadmap. With that said, we do not have all of our industry certifications completed. We understand that they're important. They take time. We'll get there. Our customers are ultimately responsible for security and compliance of their services and applications, and the Windows Azure is nothing more than just a platform. And you know that, right? When we start talking about Windows Azure and we get to this discussion of security, I am fond of using this phrase. Your data is your data. If you choose to put it on a Microsoft data center, it's still your data, and the responsibility for securing it needs to sit in your lap. That means Microsoft cannot simply take control of your stuff and do with it what they want. It's still yours. With that knowledge, you're probably saying, well, it seems logical that some of my stuff will fit very well into a public cloud environment, but there's probably a segment of my data that I'm going to want to keep only internal to my organization. And if those are the thoughts that you're having, you're absolutely right with them. Now, that doesn't mean that at some future day Microsoft may not complete their compliance and certification options so that, you know, they have, for example, HIPAA compliance. We're not there yet. We'll get there, right? Maybe they'll get PC compliance. We'll get Sarbanes-Oxley compliance. Eventually, all of those things will come. They aren't there yet. And so when we think about working with cloud-based environments, logic says, not everything belongs in Windows Azure, at least not yet anyway. With that said, you're probably thinking, hey, I'd like to get in and use Windows Azure. I'd like you to actually go out and try it as well. I actually put this up on my blog yesterday, so it'll be prepared for this morning. If you would like, you're more than welcome to go out and try Windows Azure for 30 days for free. And you can try it on me. Use the code that's listed here on the screen, DPEWR02. I work for Microsoft's Data Platform Evangelism team. That's DPE. I work in the West region. Code for me will be 02. If you will click on the tickets right here, it will actually take you to the registration page. I'll drop in so that you can see what it looks like. You really only need a couple of things. You're going to use your country. In my case, I happen to be in the United States. You'll notice that this is available all around the world. And then we're going to enter a promo code, which for me I said DPEWR02. And then you'll notice this, no credit card required. And that's what I wanted to call your attention to. I know that there are a number of trials for Windows Azure that are out there that are essentially give us your credit card information and we'll give you the first month for free, and then we'll start charging you thereafter. In this case, I'm not interested in your credit card information. I'm interested in you getting an experience with Windows Azure so that you can start to learn about it, understand it, and see where its value might lie for your organization. So go out, use the code provided. Again, no credit card required. The link for that, you can use windowsazurepass.com. You can also go to blogs.technet.com/chenley, and I will actually put that information on the slides before the end of this presentation. Let's drop back out of here, and we'll get you into some more discussion. So I know you're thinking to yourselves, hey, what about the private cloud? Let's talk about the private cloud, because that's where we're going to go for the next 3 solid weeks. When we think about the idea of private cloud, you're going to take all of the components that we just discussed in our prior discussion and bring them internal to your organization. And that's going to work in one of 3 ways. Now, if you're into the easy, fast, pre-validated model, you can go out and purchase a pre-validated private cloud configuration, hardware and software administrative components from one of our Hyper-V Cloud Fast Track providers. These are big names. I'll show them all to you in just a few minutes. You could go out and find a service provider. So you could go out and find someone who's going to host Hyper-V Cloud services on your behalf, and they may dedicate those services specifically to you. You could, of course, build your own private cloud, which is what this series is all about. From a service provider listing, here are some of them. You're welcome to go out for a complete list. You can see there, Microsoft.com/virtualization. If you'll click on Hyper-V Cloud Service Providers, there's a long list. They're from all around the world, and they provide everything from infrastructure as a service offerings to hosting offerings, web hosting, managed hosting, you name it. The services are out there. So even if you don't have a strong cloud background, you're welcome to go out and use them. Service providers can provide you significant savings. I threw in a sample here. Hostway Corporation, new virtual servers will help host or cut IT work and save $2 million annually. Oh, it's worth reading the case study. Go out and learn a little bit more about how they're doing this. Somebody throws up, I'm saving $2 million annually. I'm interested in how they're doing it. I told you that you can buy a pre-validated private cloud configuration. You can work with Dell, Fujitsu, Hitachi, HP, IBM, NEC, NetApp, or Cisco. Those 8 providers have worked with and have certified Hyper-V Cloud private cloud environments that you can partner with and work with directly. They can bring it right into your organization, or you can share their resources with them. If you're into building your own private cloud, which I think is a great idea personally, your private cloud will deliver many of the benefits of your public cloud environment. The reason I spent time today on Windows Azure is because I want you to get familiar with what cloud components are available and what cloud components you might want inside of your environment. Self-service is very desirable. Scalability, elasticity, that fabric concept, the automated IT concept are really desirable in building your own private cloud. Now, when you're building a private cloud, you're going to use Hyper-V as the base for your private cloud environment. And all of our providers do the same thing. Remember, Windows Azure is really just a virtual machine. Hyper-V is used to manage the resource pools associated with the resources that are going to go into your private cloud. Now, there's something called the Hyper-V Cloud Deployment Guides. You can find them at Microsoft.com/virtualization. Click on the private cloud link. Before you come back to next Friday's session, I want you to go in and I want you to look at the deployment guides for Hyper-V. You're going to learn architecture, deployment, operations, and they actually have a project plan and template that's there for you as well. So you can get an idea of what this process is actually going to be like. In addition to Hyper-V providing the backbone, we're going to get a lot of benefits out of Hyper-V for our public cloud. So we're going to use Hyper-V to get availability, management through virtualized data centers. Specifically, we're going to use PowerShell and System Center Virtual Machine Manager. We're going to get virtual network capacity through Hyper-V. So we're going to use Virtual Network Manager, VNM, or we're going to build our own virtual switches, virtual networks with Hyper-V. We're going to run simplified deployments for both physical and virtual computers using Hyper-V as the basis to do that. So Hyper-V on Windows Server 2008 R2 becomes a critical component of building our own private cloud. We're going to use System Center Operations Manager. It's going to give us our scalable virtualization and management tool set. Business agility is huge. Remember, we like this idea of flexibility, and System Center gives us a lot more flexible environment to work with than something like, say, our standard virtual machine manager out of Hyper-V. We're going to use System Center Virtual Machine Manager and something called the Self-Service Portal. Now, that Self-Service Portal is going to do our data center resource allocation. Now, this is where we're starting to combine the tools to get the benefits of Hyper-V, System Center, and Virtual Machine Manager and start to automate that IT process to get true IT as a service. So in this case, we'll start to do things like infrastructure provisioning and validation. So I can, instead of telling it what to do, instead of telling it how to do it, I can now start telling it what I want to do and let the systems take over and figure out the hows. And System Center, with its self-service portal, is an excellent tool for using provision management, extensibility, onboarding, stuff like that is so easy to do with Virtual Machine Manager. And in the coming weeks, we'll spend a large amount of time talking about how to do each of these concepts. Now, we always seem to swing around to where we began, and it looks like we're going to do that here. I told you that one of the partners for us is Fujitsu, and this last week, I know the slide says today, but that was actually a week ago that it occurred, Fujitsu and Microsoft announced the upcoming August 2011 availability of the Fujitsu Global Cloud Platform Service. Now, that is the most obscure term I can imagine. Let me tell you what's happening. Fujitsu has built a Windows Azure appliance. That means you can now go to Fujitsu, say, I want Windows Azure, but I want it as an appliance to run in my private cloud. The new service offering has already been running in Fujitsu's data center, yada, yada, yada. The point is, come August, you can have all of those functional components of Windows Azure in your private cloud environment using a Windows Azure appliance. And so we kind of come full circle. We will use Hyper-V. We will use System Center. We will use System Center Virtual Machine Manager, and we will likely use Azure appliances as we build and evolve our private cloud solutions. Some additional resources that you might want to use. If you'll go out to Microsoft.com/virtualization, you'll find on that website a launch point for the majority of Microsoft's resources around public cloud, Windows Azure, private cloud components. There are white papers, case studies, deployment guides, partner information there, everything that you might use to get started with public and private cloud you will find there. In addition, technet.microsoft.com has a virtualization page. That page contains links to webcasts like this one, videos, additional white papers specifically around the virtualization strategy that we're going to start talking about in next Friday's webcast. It's worth spending a little bit of time there, do a little bit of homework. Last but not least, I put my blog location here. I told you all that I would give that out, blogs.technet.com/chenley. Please don't hesitate. Visit that site, if for nothing more than to get access to that free Windows Azure 30-day pass. Feel free to also contact me through that blog location. I also put content there that is related to cloud. You'll notice that there's a fair amount of stuff that I do around virtualization and cloud computing that will continue. There are also free resources there, and you can go and find information about live events, webcasts, and even office hours that I'm doing. Always look forward to working with you in other capacities besides just webcasts. So please don't hesitate. Get out there and use those resources. Well, at this point, I'm looking at my clock. It's the top of the hour. It's probably time for us to kind of get things wrapped up and concluded. What I'd like to do is this. You all have been kind of quiet in the Q&A pane today. If you would like, take a second, hit the Ask button. If you have some questions, let's get those into the question and answer segment, and we'll take some of those for a few minutes. In the meantime, your feedback is really important to us. So what I'd like to do is turn you on to a survey that we have and have you take a couple of seconds while we're doing question and answers and fill out the survey for us. And on that note, I'd like to thank you for participating. I'm going to turn the time to Scott to get you started on the survey, and I'll head to the question and answers pane and start looking at some of the questions that you have. Scott, the time's yours.
Thanks, Chris. So if you have questions for our presenter, please go ahead and submit that now using the Q&A pane, and he'll be getting to those in just a minute. You should be seeing a new page in your slide area with links to a survey. If you could take a moment to fill that out before you log off, we do appreciate any feedback you leave for us. All you need to do is click on the links provided and fill that out. So with that, I'm going to hand the floor back over to Chris to wrap up with any questions.
Well, Scott, there's nothing in the question and answer pane, so I'm going to throw a few in there on my own, if that's okay.
Sure.
First question. Hey, where do I go to find out more information and resources about private cloud? Two things I'd recommend. I already told you about the Microsoft private cloud site. Webcast is a great way to get more information about private cloud. This session has been a 100-level session. We're going to step up the private cloud discussion. Next week, we're going to start talking about Hyper-V. The following week, we're going to do some work with System Center. And then the week after that, we'll work with System Center Virtual Machine Manager and get you familiar with the actual step-by-steps of how to build your own private cloud environment. In addition, I would encourage you to watch myself, Harold Wong, who is the Chief Technology Evangelist for Cloud in the United States, and Chris Avis will be doing a series of live events where you can come and spend 4 hours with us, and we'll actually build a private cloud together in that event. Those will be taking place starting the end of July. Watch my blog for those. I don't actually have live registration links yet. I'm assuming we should have those before Tuesday of next week. But please come and attend some of that content with us. It doesn't look like we have any additional questions in the queue, so I think we're probably about done in terms of time. I don't want to go over too much. Scott, I'll go ahead and turn the time back to you to conclude the webcast. Thanks to all of you for attending today.
I'd like to extend a special thanks to Chris Henley today for his presentation, and thank you all for joining us. You may disconnect from the audio portion of today's conference.